In the figure, an external force P acts on the body of mass 10 kg. The coefficient of friction mu equals 0.4. A. Find the magnitude and direction of the frictional force and the normal reaction for 1. P equals 10 Newton. 2. P equals 30 Newton. 3. P equals 56.6 Newton. 4. P equals to 70 Newton. B. At what value of P is motion impending up the plane? Now, we have our plane like this. It is 30 degrees to the horizontal. Another force F is acting on the block. It is 30 degrees to the plane. Force P, sorry. And the weight of the body is 10g. Straight downward. There is a normal to the surface of the plane. And we have frictional force. It can act in this direction, it can act in this direction, depending on the direction of the motion. That is, it can act to the right or left of the normal. Now, for ease, let's resolve these forces along the plane and perpendicular to the plane. So this 10g, if resolved, I'm going to have perpendicular to the plane down here. I have 10g cos 30 degrees. And I have 10g sin 30 degrees down the plane. So these two are summed up to the day. So this one is gone. Now let's look at this one too. I have P sin 30 degrees perpendicular to the plane and P cos 30 degrees along the plane upward. So I have removed the P. These two sums up to that one. So it makes it easy for me to work this now. To find n plus P sin 30 degrees will be equal to 10g cos 30 degrees. Why? Along the perpendicular, there is what's it called? Equilibrium. The body is not jumping up and down, and so they are fully in contact. That is why n will be 10g cos 30 degrees minus P sin 30 degrees. So this shows that the greater the value of P, the lesser the value of n. Now, along the plane, that is where motion, tendency of motion will take place. So it depends. If 10g sin 30 is greater than P cos 30, there will be a resultant force downward, and frictional force will be upward. If P cos 30 is greater than 10g sin 30, there will be force upward, and there will be frictional force downward. So let's work that out. I try to decide which. Okay, let me make F the balancing F, that is after subtracting this one from this one. Let's take this one as our arbitrary value for F. Arbitrary value for F. Arbitrary direction for F. Assuming that this one is bigger than this. But if this one becomes negative, it means that this one is greater than this. And we know what our friction is. Our friction will come downward. So let's make F, let's find the net force along the plane. So F will be equal to 10g sin 30 minus P cos 30 degrees. So it makes our job easier and to analyze. Please note, just because of time, it's easy also to use graphical method and to use so many other techniques. It's fun, but for this, if time permits me, I'll be able to do it. That's fine. When n equals 10 Newton, when P equals 10 Newton, when P equals 10 Newton, let's find the value of our n. N will be equal to 98.1, that is 10 times 9.81, cos 30 minus 10 sin 30, and that is equal to 79.96 Newton. Let's now find what will be the value of our F. If this one is greater than this one, our F will come here, friction will go up. So let's find the resultant force along the plane. Resultant force along the plane will be 10g sin 30 minus 10 cos 30 degrees. And that is 40.39 Newton. So which means that the resultant force is 40.39 Newton downward. The greatest value of frictional force, because frictional force will counter the resultant force. So frictional force developed, that is maximum, please, possible. The maximum possible frictional force that the surface can generate due to this arrangement is going to be 0.4 mu n, which is 0.4 times 79.96 Newton. And this one will be equal to 31.984 Newton. So this will act against the force that is developed. Therefore, after the frictional force has acted on the surface now, and F has acted down, there will be a resultant force of 40.39 minus 31.984 Newton downwards, and that is 0.406 Newton downwards. So since you have a resultant force downwards, the frictional force is not up to the force generated, up to the force, resultant force created by the arrangement. The frictional force is not up to the resultant force along the surface. There will be motion downward. So there is motion downward and friction is up the plane with value 31.984 Newton. Why do we say this? Because because it can overcome this, there is motion. That's a simple explanation for that. Now let's check when P is equal to 30 Newton. Now let me simplify this one further so it will be faster in handling. So N is equal to 98.1 cos 30. That is 84.96 minus P sin 30 degrees. F is equal to, which is 49.05 minus P cos 30 degrees. So it will reduce the time. Now when P is equal to 30 Newton, N is equal to 84.96 minus 30 sin 30 degrees. So and that's going to give you that is 69.96 Newton. The resultant force on the surface will be equal to 49.05 minus 30 cos 30 degrees. And that is that's 23.07 Newton. You can see. So it means that you have a total force down. So it means that you have a total force of 23.07 down. Therefore, there will be a frictional force upward. So in this instance, there will be frictional force upward. Let's see if this one is up to the limiting friction. So possible limiting friction will be equal to 0.4 times 69.96, which is 27.984 Newton. So which means that the total force generated by this arrangement is not up to the frictional force upward that should be overcome. So frictional force the magnitude of the frictional force is 23.07 Newton. Please, I hope you understand. This is the maximum possible frictional force that should be overcome. And the force generated is not up to this frictional force that should be overcome upward. So the frictional force yet developed is 23.07. That is it. And it is upward the plane surface. But because the frictional force developed is not up to the limiting frictional force, no motion. So you can see, no motion now. The other one there was motion. Now let's check when P equals 56.6. So when P equals to 56.6, N will be equal to 84.96 minus 56.6 sin 30 degrees. And that is 56.66 Newton. So our normal in this instance is 56.66 Newton. Let's see what the frictional force and the total force developed on the surface will be. F will now be equal to 49.05 minus 56.6 cos 30 degrees. And that is 0.033 Newton. So what do we have? We have almost zero as the frictional force, as the total force developed on the due to the arrangement of the forces. Please take note. Due to the arrangement of the forces, the total force along the plane is 0.033 Newton. And from what I have done, it is towards down. So let's now look at it. Regarding motion or no motion, and which direction is the frictional force going to act? For our frictional force, the frictional force is equal to 0.033 Newton. Now, why? Because I know 0.4. The limiting frictional force that ought to be developed for motion to take place at all is going to be 56.66 times 0.4, and that is 22.664 Newton. From what we have seen, the force is downward. This F is downward. You can see. And it ought to overcome this frictional force that is acting in the opposite direction. So this is how it is. We have 0.033. And now the frictional force is 0.033 Newton. For motion to take place, the force downward must be equal or greater than this one. That's what I'm trying to say. So in this instance, no motion. Friction is 0.033 Newton. That's the frictional force developed. And it's not up to the limiting frictional force. So no motion. It is stable. Now let's look at the last one. Now when P equals to 70 Newton, what is our N? N is equal to 84.96 minus 17 sine 30 degrees. And that gives me 96. It gives me 49.96 Newton. Let's see the direction and value of F. The force developed in this instance now is 49.05 minus 17 cos 30 degrees. And that is minus 11.57 Newton. So in this instance, the force generated is now upwards. So F is 11.57 Newton upwards. You can see. And the frictional force will now be downward. Friction. Let us now see the frictional force that should be overcome for motion to take place. Limiting friction is equal to 0.4 times the normal, or 9.96 Newton. And that is 19.984 Newton. So the frictional force, the force generated due to this arrangement is not up to the limiting friction. So 1, no motion. Stable. That is one thing. So the direction of the friction is down the plane. Direction of friction is down the plane. And the value of the friction generated now, value of friction generated is 11.57 Newton downward. So very simple. Just have to be in that box and follow the motion. Now, we have another question. It says, at what value of P is motion impending up the plane? P can have value that motion can be impending downward, and P can have value that motion can be impending upward. Now, let me tell you, for P to be impending upward, 10 g sine 30 will act with friction. The total friction, mu n, that is gotten, must be equal to P cos 30 in that direction. I will show you what I mean now. For impending motion up the plane, what we are saying is this: N will be equal to 84.96 minus P sine 30 degrees, and F, the frictional force, mu n, the frictional force must be equal to F, that is limiting friction down the plane, let me put it in a better way. What I'm saying is this: for impending motion, you understand? Frictional force must act downward now, and which means that the frictional force must be equal to minus F, which is mu n. The frictional force must be downward. The frictional force must be downward. And if frictional force is downward, this one will be negative. And it is equal to mu n, which is minus mu n, according to the arbitrary direction you have taken here. Or to make it simpler, for impending motion upward, impending motion upward, look at the plane. We have something like this. So P cos 30 degrees, I have mg sin 30. At the same time, there will be mu n downward now. You understand now? So in this instance, therefore, P cos 30 degrees will be equal to mg sin 30 degrees plus mu n, which is 49.05 plus 0.4 n. So you can see, and from here, I have got what n is here. I can substitute here. So P cos 30 degrees will be equal to 49.05 plus 0.4 into this one here, 84.96 minus P sin 30 degrees. So please, I hope you understand. For impending motion upward, this one should be equal to minus mu n, and that's what I'm doing here. So, but at the end of the day, I showed you the diagram. For impending motion upward, frictional force will act downward, along with mg sin 30. The two of them must be overcome for impending motion upward. So that's what I did here. Then I have P cos 30 degrees plus 0.4 P sin 30 degrees is equal to 49.05 plus 0.4 times 84.96. So I can now have something like this: P cos 30 degrees plus 0.4 sin 30 degrees is equal to, let me use calculator to resolve this, 0.4 times 83.034 Newton. So with this, I can find the value of P. So P is equal to 83.034 divided by cos 30 plus 0.4 sin 30 degrees. And that will give me, let's work that. Any motion to take place upward, there will be a force of 77.89 applied 30 degrees to the horizontal. 30 degrees to the horizontal to start the motion upward. Let's see what the frictional force will be. Let's see what the normal will be. So in this instance, our n will be equal to 84.96 minus 77.89 sin 30. And that is equal to, that's 46.015 Newton. Let's see our F. What is our F? F is the force along the horizontal. Let's see. Was 10, yes, 49.05 minus P cos 30 degrees. So, and that will be 49.05 minus 77.89 cos 30. That is minus 18.40 Newton. Yes. Which means that the force generated is 18.40 up the plane. Now let's see what the frictional force to move that this one needs now for impending motion. Let's see what it will be. That is mu times 46.015. You can see this one is 18.406 Newton. So you can see. So this F generated is equal to the limiting friction that is necessary, and it acts upward. You can see. So that is why this analysis shows it is okay. Our working is okay. The body is stationary when the force P is gradually applied What is the critical value of mu? So that the body tilts before it slides. Assume acceleration 0. So what we are saying here is this. This force P here is being applied gradually. And after some time, the body tilts. If this body is going to tilt, R here will be equal to 0. And we have the full R at this point. And if there will be tilting at all, if there will be sliding at all, it means that this P must be equal to the frictional force which will act in this direction. Therefore, P, F, in this instance, must be equal to P. But if the body is tilting, F must be greater than P. Now let's see what will be the value of P. Take a moment about this other point. Let's make the weight to be W. So W comes like this. So W times 0.4 is equal to P times 0.8. P times 0.8. And P will be equal to W over 0.8 times 0.4, which will be 0.5 W. But we know that F, for tilting, F must be greater than 0.5 W. And at the same time, F is equal to mu N, which is mu W. So mu W is greater than 0.5 W. So mu must be greater than 0.5 for tilting. For tilting. So the critical value must be that mu must be greater than 0.5 for tilting, for the body to tilt before it slides. Before sliding. A uniform plank having a mass 10 kg and length 6 meters is lying at 20 degrees to the horizontal across the channel as in figure below. The value of mu at the contact surfaces is 0.3. Determine the mass n of a small body which, if placed at point C, 1.5 meters from the center, will make the plank just slip. So what we are saying here is this, that it is at equilibrium. That is, at this point and this point, they are at the point of limiting friction. That is what we are talking about. So we will now look at the forces and the moment of the plank. Let's try. This is what we have. This is the plank, and it is 20 degrees to the horizontal. So we have it like this, and you can see this surface, because that is where the friction will occur. There will be a normal reaction like this, and there will be a normal reaction here too, like this. And these two reactions, they will be perpendicular to the surfaces. So you can see. So between this and the horizontal here, we are going to have 45 degrees. Because that one makes 90 degrees. So this one here, between this one and this place, we are going to have 45 degrees. So this place too here, we are going to have 45 degrees. Please, I want you to follow. So we are going to have 45 degrees here for the normal reaction. So this is A, this is B, NB, NA. We are going to have the normal reaction here, 45. This is NA here. Now, because this one will slide down like this, because this is where the point C is acting. This one will slide like this, and this one will slide up. So if this one comes here, frictional force will go up like this. So this will be, FA will go like this, along the surface. And for this one, because it will go up, frictional force will come down like this, FA. FB, sorry. FA has gone up. So we are going to have FA goes up. So we have FA like this. You can see. And for this one, we have FB. There will be. And on this one too, FA. So it's going to be something like this. Like that. That's what we are going to have. After this, we are going to have the proportion between this one and this one is 0.3. So this one will be 0.3 NA, and this one will be 0.3 NB. We have a force 10G here at the point middle of the plank, because it's a uniform plank. And we have NG here, the mass, 1.5 meters apart. That's what we have. Now, you can take the moment of these two forces separately. You can work on NA and FA separately, NB and FB separately, and at the end of the day, after working all through, you can get N and if whatever you like. That one might take time, but at the same time, you can also do something. Since you know the relationship between NA and NB and FA, since this one goes up, you can find RA, and for this one too, you can find RB. From our knowledge in friction, we know that the angle here phi, and the angle here is phi. And what is phi? Phi is equal to r tan mu, which is r tan 0.3. That is it. So on getting mu, we have 6999. So this is approximately 16.7 degrees. That is what we have there. Approximately 16.7 degrees. So, which means I can do away with this. This one will be 16.7 plus 45. That's what it's going to be to the horizontal. So I'm going to have 16.7 plus 45 there, and that is 61.7. So everything from horizontal to this place, or this one will go off. I'm going to have 61.7, or from this place to this place. So this place to this place now will be 41.7. That one like that. For this one too, this is 45. From this place to this place will be 45 minus 16.7. So that is 45 minus 16.7. So that one is going to give me 28.3. So I don't need this again. So this is 28.3 degrees. So from this place to the horizontal is 28.3. But from this place to this place is 48.3. That is if I need it. So let's work with what we have now. 28.3 to the horizontal, and this one is 61.7 to the horizontal. So I don't need this one again. I have gone to now. Let us now work based on equilibrium. Let us resolve the forces. Summation Fx will be 0 at equilibrium. Therefore, the forces to the right will be equal to the forces to the left. So we have Ra cos 61.7 is equal to Rb cos 28.3. And if you look at it, Ra will be equal to Rb cos 28.3 over cos 61.7. Looking at it, you see that the sum is 90. So we can say that Rb tan sine 61.7 degrees over cos 61.7 degrees, which is Rb tan 61.7 degrees. So that's Ra from the first. Now let's look at the forces in the vertical direction. The upward force will be equal to the downward force. So Ra sine 61.7 degrees plus Rb sine 28.3 degrees is equal to 10 plus n into g. So these are the forces down. Now let's find, we have discovered that Ra is equal to Rb tan 61.7. So let's work it out now. So this one will be Rb tan 61.7 degrees sine 61.7 degrees plus Rb, and you know, so that I don't waste time, this one will be cos 61.7 degrees. Let me leave it. Sine 28.3 is equal to 10 plus n into g. Therefore, we can have everything in terms of Rb. Now let's take the moments about Ra. Moment about Ra is equal to 0. Summation Na will be equal to 0. That is, clockwise moments about A will be equal to anti-clockwise moments. Clockwise moments is equal to anti-clockwise moments. Therefore, this place to this place is 1.5 cos 20. This place to this place is 3 cos 20. So I can say mg times 1.5 cos 20 plus 10g times 3 cos 20. You can say. Now, I can use Varignon theorem. Break this one along this direction and along this direction and take the moments about this place. You can do it like that. Take the moment by multiplying the component here by this distance and the component here by this distance. I can do it like that, but not necessary. I can also do it like this. So the line of action of RB, that is perpendicular distance from here. So what is the perpendicular distance from here? This place will be 6 sine 48.3 degrees. If you look at it, the total angle here is 48.3. So this place will be 6 sine 48.3 degrees. Therefore, I can now say is equal to RB times 6 sine 48.3 degrees. And I know what RB is here. From here, let me make this one 1. From 1, RB is equal to 10 plus n into g divided by tan 61.7 degree sine 61.7 degree plus sine 28.3 degrees. I don't want to be breaking it down further. So that is RB. Before I continue, let me divide through by 1.5 cos 20. Therefore, let me call this one 2. From 2, mg plus 10g will be equal to, oh sorry, because I'm dividing through by 1.5 cos 20, I can now say mg, this one will be 2, plus 20g will be equal to RB sine 48.3 times 4 divided by cos 20. Because 1.5 here is 4. So that gives me this. So let me continue. And RB is giving me this. So RB, I now substitute RB from here to here, please. So I have 10 plus n into g over cos 20 into tan 61.7 degrees sine 61.7 degrees plus sine 28.3 degrees. And this one times 4 sine 48.3 degrees. So let me check. This is RB. I brought it down here. This is RB. 10 plus ng. That is RB. So this cos 20 is here, and this sine times 4. Now let's find what this one will give us. I can now say, let me divide it by g. N plus 20 is equal to 10 plus n into, let me get what this one will be. So this will be 10 plus m into 1.5067581. Okay, let me stop it like that. Now, so let me bring the like terms together. I'm going to have 20 minus 15.067581 is equal to 1.5067581 minus n. Minus 1, sorry. So n will be equal to 4.932419 divided by 0.5067581. So that is going to be our n. And n will give us approximately 9.733 kg. So that is what our n gives us. Another way you can look at it is by considering the equilibrium and drawing out the equilibrium triangle. So at equilibrium, we are going to have something like this. AB, and we have 28.3, and we have, so this is 61.7, and at the point of intersection of these two, this will be the point of the resultant of the force of M and 10. So all of them must interact, and let's call this place K. We have this place A, B, and this is K. So this force and this one, this resultant must pass through this point, and that is how we get the once we get this point, the moment of this one and this one about this point will balance because that's where the resultant pass through. Now let's work it out. From here to here is 20 degrees. So from here to here will be 41.7 degrees. From here to here will be 48.3 degrees because this place is 20. And this place to this place is 6 meters from the question. And if you look at it, this one passes through this place. This place is 20 degrees. So this place is 70 degrees. That place is 70 degrees. Automatically this place is 110 degrees. That place is 110 degrees. So because this place C, and we have said the distance from here to here is 1.5. And this angle here, we have said that it is 20 degrees. So we are going to have let us now turn our triangle so that it will be very easy for us to angle. Now, I have something like this. I have it like this. I have this like this. That is 48.3. This place 41.7. Now, on analyzing this, I realize that this place and this place is 90 degrees. So this place will be 90 degrees. And this is A, this is B. And this is K. Now, from K to the point, this is the point. We have the resultant of mg and 10g passes through. So I realize that this place is 70 degrees. So this place is 110 degrees. And this place is 90 degrees. I have gotten that one. Now, this place is 6 meters. For ease, let me find this place. And from there, I can find this place. This place is 41.7. This place is 110. And this place will be 8.3 degrees. That is 28.3 degrees. Now, I can easily find all these other ones. Since this place is 90 degrees, I have right angle. And from there, this place will be 6 sine 48.3 degrees. So this is it. This place will be 6 sine 48.3 degrees. That's AK. So here, let's call this place D. And so this place will be D. So AK is 6 sine 48.3 degrees because it's facing this angle. Now, using sine rule, AK over sine 110 degrees is equal to AD over sine 28.3 degrees. Therefore, AD is equal to AK sine 28.3 over sine 110 degrees, which is 6 sine 48.3 sine 28.3 divided by sine 110 degrees. And so let's see what the distance of AD is. It's equal to 2.26 meters. So since AD is 2.26 meters, the distance of C from D will be, so CD is equal to 2.26 minus 1.5, and that is equal to, and DG, that is, we have the weight of the plant passes through will be 3 minus 2.26, and that is, let's see what it will give us, 0.74 meters. Now let's find what our M is from the knowledge of moments. The sun will pass through this place, and the moment about this place will be 0. Therefore, M times mg times cg will be equal to 10g times dg. And let me call this. So M will be 10 times dg over cg, which is 10 times 0.74 divided by 0.76. And what does that give us? 737 kg. So that is another way of finding M. That's another way of finding M. A uniform plank of length 5 meters and mass 50 kg is standing on a horizontal floor and leaning against the vertical wall. At the floor, the coefficient of friction is 0.3 and the wall is 0.2. The plank is placed at an angle at tan 0.6 to the vertical. Determine the range of values for the normal reactions and frictional forces at the floor and the wall. That's one. Second part says, at what angle to the vertical must the plank be placed for slip to be about to occur? Now, this is what we have. We have a scenario like this. This is the plank. And we have a wall. And we have a floor. And it is 5 meters long. You can see. and it's uniform, which means that from here to here is 2.5 meters, and also from here to here will be 2.5 meters. We know that at this place, yes, we have a normal reaction, and at this place too, we have a normal reaction. So let's call this place A, let's call this place B. So I don't need this again, this is just for illustration. So I have A and B. Let's call this normal reaction here NB, and normal reaction here NA. Now, we have this is 50G. Here G is 9.8 meters per second. Yes. Square. So we have it like that. Now, depending on where motion is tending to, that is what will determine the direction of the frictional force, and other things that we might need to talk about. Now, if the motion is tending towards this place, frictional force will come here. And if motion tends to this place, motion will come here, and frictional force will go up. And here is 0.2. Here 0.3. Now let's look at if the motion is tending towards here, what will be the reaction here, frictional force here, reaction here, frictional force here. And you must note that motion will not take place at the same time. Motion might not take place at the same time, depending. So we have to find, using moments to find the reaction and friction here, using moment to find the reaction and friction here, and we will now pick the ranges. So let's look at, let's say NA, FA, NB, FB. So we'll be able to know the values, and then we'll be able to pick the ranges. Now let's start. Let's take moments about, let's take a moment about B for this situation. Let's say, okay, the motion is impending at this place first. Let's take it, and it is towards up, and this one is friction towards this place, and the friction here is also upward. So let's see. Summation MB is equal to 0. Therefore, for this one, we have FA. This place is 5 cos theta. Here is 5 sin theta. So the distance from here to here is times 5 sin theta. This one plus NB times 5 cos theta minus 50G times 2.5. Can you see? From here to here, 2.5 sin theta. We are told against the wall. Sin times 2.5 sin theta is equal to 0. Now let's quickly get this. Here we have f divided by 2.5, 2 and 2. Cos theta. Here, tan theta and tan theta. At the end of the day, you know that this place is going to be 0.2 NA because we have estimated that motion is impending here. So we have 0.2 NA times 2 tan theta plus NA times 2 is equal to 50G tan theta. You can see. So when I divided through by cos. So let me now bring this here. I'm going to have NA into what is called, what is this? NA, this one is 0.6. So 1.2, 0.24. So 2.24 is equal to 50 times 9.8 times 0.6. So NA will be equal to 50 times 9.8 times 0.6 divided by 2.24. So that will give us 131.25. So if I have this one as 131.25, what will I have here? FA will be equal to this one times 0.2. But motion, we have said that we assume motion is impending here. So this one is 26.25. So, and from this place we can see that FA plus NB must give us 50G. So NB in this situation will be equal to 50 times 9.8 minus 26.25. So that will give me 0.75. You know, we don't know if motion is impending here or not. So I will be able to get the actual value of FB. But I can say that FB in this situation, because it is in equilibrium, FB will be equal to NA here. FB and NA will be equal because this one must for equilibrium. So FB will be equal to 131.25. So if you look at it, 131.25 times 0.3. No, 463.75 times 0.3 is 139.125. So motion is not impending here for down. Now let's check if with this situation motion is impending here. Let us see what the values will be like. Let us see if motion is impending at this place now. We are going to have yes NB times 5 sine theta plus minus, because this is anti-clockwise, this one is anti-clockwise, this one is clockwise, minus FB times 5 cos theta, and this one is also clockwise, minus 50G times 2.5 sine theta. We are taking the moment about A, please. Moment about A to be equal to 0. But in this situation, we have said that FB will be, if it's impending, it means that this FB is 0.3 of NB. So we are going to have, okay, let me divide 2 by 2.5 like I did the other time. 2, cos cancel, tan theta, tan theta. And we know what tan theta is 0.6 from the question. So we have 2 times 0.6, that is 1.2, minus 2. We know that FB is 0.3 NB from this, times 0.3 NB will be equal to 50G tan theta. So what do we have now? So NB into 1.2 minus 0.6 will be equal to 50G times 0.6. So we see that NB into 0.6 is equal to 50G times 0.6. You can see. So this one cancels this. So in this instance, you see that NB is 50 times 9.8, that's 490. That is 490 Newton. So please, everything is Newton. So in this instance, if NB is 490 Newton, FB will be 0.3 times this from our assumption. 490 times 0.3. That is 147. And if you look at this now, if NB is 490 and this one is 490, it means that FA is 0. It means that FA is 0 and NA, because this FB must be equal to NA. You can see. So NA will be equal to 147. So from this, we can see the ranges of value that we can have already for the forces. So for NB, that is reaction, normal reaction at the floor is 463.75 to 490 Newton. FB, that is frictional force at the floor. Frictional force at the floor is 131.25 to 147 Newton. You can see. Now for NA, that is the reaction, normal reaction at the wall, we can see that it is 131.25 to 147 Newton. For NB, FA, frictional force at the wall, we can see that it ranges from 0 to 26.25 Newton. So it's very simple and straightforward. Simple moments. It's just knowledge of simple moments that we need to solve that one. We have another part of the question that's asking us. At what angle to the vertical must the plan be placed for slip to be about to occur? That is, they are both at equilibrium. What they are saying now is, at what point will the motion be bending here and be bending here at the same time. At what value of theta will that occur? Now let's see. This is just testing our knowledge of trigonometry. We have something like this, and you have theta. So we have normal reaction here. We have mg here, and we have F like this. The motion is Fa, Nd. And we also have Fb, Nd, the normal reaction to the wall. And if motion is bent like this, motion will come here. So we have Fb like this, because this motion is coming down here. This is direction of motion, impending motion. So we know that this one is 0.3 NA, and this one is 0.2 NB. Now, you can resolve it like this. Put it like 0.2 NB and find your moment. You will get it. So, because of you have done something similar to that, like that in the past, I want to show you the simple way now. At that moment of sleep about to occur, we have said that this one is 0.3 NB, this one is 0.2 NB. 0.2 NB. Now, the angle between this one and the total reaction from our knowledge before, this one is going to be arctan. Let's call this one phi 1. Here, let's call this one phi 2. And the two of them must meet the line of direction of the weight. You can see. And we have known that it is uniform plank. So we know that this place to this place is 2.5. This place to this place is 2.5 meters. And this one, you can see it goes down like this. So now let's find our phi 1, phi 2. Phi 1 is arctan 0.2. Phi 2 is arctan 0.3. So let's find the value for this. 11.31 degrees, and this one is 16.7 degrees. So let me leave this one as 11.3 degrees. Let me leave that one. So that's 11.3, 16.7 degrees. Now, if this one is 16.7 degrees, the angle from here to here will be 90 minus 16.7 degrees. Please take note. This place is 16.7 degrees. So this place will be 90, because this place is like this. It will be 90 minus 16.7 degrees, and that is 73.3 degrees. Note, we don't know phi. That's what we are trying to find. We don't know theta. Sorry. Note, we don't know theta. That's what we are trying to find. So, from here to here will be 90 minus theta. Will be 90 minus theta. And sorry, I don't even need this portion. This place is 11.3 degrees. Fine. I have gotten what I need now. Let us call this place x. X. The distance from x to this place. You know, this place is C, the center of gravity. Let's call this place D. So xd. Let's call xd to be equal to h. So this place is h meters. Now, from here to here is 5 meters. And from here to here is 2.5. From here to here is 2.5. So this place, as you can see, will be 2.5 sine theta. So from here to here is 2.5 sine theta. And from here to here is 2.5 sine theta. So we are just trying to use our knowledge of trigonometry. Now, from this place to this place to this place is 5 cos theta. And this place to this place, since you have seen that this place is 2.5 sine theta, this place to this place will be 2.5 sine theta tan 11.3 degrees. And this place, H, is 2.5 sin theta tan 73.3 degrees. So let's start working it. H is equal to 5 cos theta from here to here, plus this place, plus 2.5 sin theta tan 11.3 degrees. Then our H here is also equal to 2.5 sin theta tan 73.3 degrees. So now let us now equate these two. I have 5 cos theta plus 2.5 sin theta. Please let me put in this value back for tan times 0.2 is equal to 2.5 sin theta. We know that this one is 73 minus 90 minus this one. Doing here. So tan 73.3 will be 1 over tan 16.7 degrees. So that's why I replace this one here. Now we are gotten to a simplified solution. Let's divide through by 2.5. Here I have 2 here. Let's divide through by cos theta. I have cos cancelled, tan theta, and I also have tan theta. Good. So I will now have 2 plus 0.2 tan theta is equal to 1 over 0.3 tan theta. Therefore, 2 will be equal to 10 over 3 minus 2 over 10 tan theta. You can see. So at the end of the day, I'm going to have this is 100 minus 6 over 30 tan theta. So tan theta will be equal to 2 times 30. 100 minus 6 over 94, which is equal to 60 over 94. So theta will be equal to half tan 60 over 94. And that is equal to, okay, let me write it clearer here. From here, so tan theta is equal to 60 over 94. So theta will be equal to half tan 60 over 94. And that is 32.55 degrees. Approximately 32.6 degrees. So when theta here, that is the angle the plan made with the horizontal is 32.6 degrees. There is impending motion slip at both sides. There is impending motion at both sides.